Hey, it seems like it's been a while since I made one of these videos, but in this we are going to talk about synthesis or composition reactions. This is the very first kind of chemical reaction we're going to discuss, and it's actually one of the easiest ones we're going to discuss. So, for synthesis or composition reactions, sometimes they're called either or. Basically what happens is you have two or more substances that come together to make a single substance. Basically, you have two or more reactants and it always makes a single product. Now this one's missing its arrow here, so let me just draw a little arrow. But again, the general equation is A plus X yields AX, where A is something, some element, X is some element, and they just come together. So I like to think of chemistry kind of like romance in a way. And every kind of reaction you're going to find out has a different kind of romance. So in synthesis reactions, it's a love story. You have a single person A and a single person B who are single at first, then they get together and they become a couple. And that's synthesis. So again, it's two singles become a pair. Two singles become a pair, and that's it. That's synthesis. So where does this get hard? Well, one, you have to identify synthesis reactions. But that's actually pretty easy because, again, you know synthesis when you see it because there's always just one product. There's only one product. That's it. One product only. The hardest part is knowing how to write all the different kinds of synthesis reactions. So, for example, the first one here is reactions with metals and oxygens. This is a kind of synthesis reaction. In this, metals react with oxygen and they form a metal oxide or a metallic oxide. The basic equation is M plus O2 yields MO. This M stands for the metal. So it's whatever metal, any metal plus oxygen, which is O2. Now, in the previous lesson, in the old notes, we should have talked about, or you should have read about, diatomic molecules. So these are elements that are always a subscript 2 when they're by themselves. Always. But it's only when they're by themselves, and there's 7 of them. There's hydrogen. What's the next one? Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And the reason why I wrote it like this is because if you look on the periodic table, notice there are, again, 7 of them. There's 7 of these. And on the periodic table, if you don't count hydrogen, they actually make the number 7. So if you find them on the periodic table, you see that actually makes the number 7. So that's an easy way to remember. There's 7 of these and they make the number 7. So again, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Whenever these elements are by themselves, they always have a subscript 2. They are called diatomic. Di means 2. So let me erase these real quick. But what's going to happen is I take any metal, add it to oxygen, and I make a metal oxide. So for example, it says, write the word and chemical formula when oxygen reacts with sodium. Alright, well, the word would be, the metal in this case is sodium. So I say sodium. It's kind of hard to write with this. Plus oxygen. And what do you get when you put sodium and oxygen together? You get sodium oxide. Notice it's oxide over here because it's an ion now. It had to be an ion. It had to combine with the sodium. Right here, it's just oxygen. It's not connected to anything. It's just oxygen. So now I have to write the chemical formula. So sodium is Na. Oxygen's diatomic, O2. And then sodium oxide. You got to balance the charges. Na, it's +1. Oxide's O, it's -2. So I need 2 sodiums, 2 positive ones. So Na2O. Now, we just finished going over balancing equations. This is not balanced. I have one sodium here, two sodiums here. I have two oxygens, one oxygen. I have two oxygens, I have one, so I ask myself, what can I do to make this 2? Well, I can multiply it by 2. So if I put a 2 in front, that gives me 2 oxygens now. And then how many sodiums is this? This is 4 sodiums. I only have 1, so what can I multiply 1 by to get 4? Well, multiply by 4. That's why I did the oxygen first. Usually you want to do oxygens last when we get to more complex equations. But in this case, if I would have done the sodiums first, I would have put a 2 there, and I'm like, oh, I have to erase it because it's not right. And so I just did the oxygens first. I did a shortcut. But again, this is again what I did. So you have to memorize whenever you add a metal and an oxygen, you get a metal oxide. So again, you just write down whatever the metal is plus oxygen yields the metal oxide. That's it. So let's pretend it was aluminum. Aluminum plus oxygen, aluminum oxide. And then you have to write the formula. Okay, this is the main thing right here, writing the formulas. This is the most important part. So important. The next one, okay, to be honest with you, I rarely ever give you a question over this stuff. And if I do, it's always this same example. But again, let's say you have a nonmetal plus oxygen, it makes a nonmetal oxide. So carbon plus oxygen makes carbon dioxide. Remember, there's two nonmetals. Two nonmetals is covalent. That's when we have to use these prefixes, which is C plus O2 yields CO2. But I will almost never give you questions over nonmetals plus oxygens. Almost never. And if I do, it's always this same reaction. It's always the same reaction. So this is not a big one to remember. The next one is super important though. Metals with sulfur. So again, whenever you have a metal reacts with sulfur, it makes a metal sulfide. Now, we talked about diatomics earlier. Sulfur is an octatomic, meaning, or not octatomic, octomic. There we go, octatomic. Can't have two A's together. It always has an 8 when it's by itself. Sulfur is always an 8 when it's by itself. But again, the pattern's so obvious. I take whatever the metal is, plus sulfur, and it makes metal sulfide. Metal sulfide. Write the word in chemical formula when there's a reaction between rubidium and sulfur. Well, rubidium's a metal, so I'll just say rubidium plus sulfur. That's very ugly. Makes rubidium. Remember, you just write the metal. Man, this is ugly. Oh well. Rubidium sulfide. Rubidium sulfide. So the words are really easy. Now comes the hard part, the formula. So rubidium is Rb. Sulfur, I just said, is octomic, meaning it has to have an 8 when it's by itself, and only when it's by itself. And then rubidium sulfide. Rubidium, Rb, it's +1. Sulfide is S, it's -2. So to balance the charges, I need 2 rubidiums, 1 sulfur. Because again, this is +1, this is -2. Now I need to balance. I'm going to cheat and do the sulfurs first. Again, I have 8 sulfurs here, 1 sulfur here. What can I multiply the smaller one by to get 8? Well, multiply that by 8, so I put the coefficient 8 in front. That gives me how many rubidiums? Good. 8 times 2 is 16. I have 1 rubidium, so what can I multiply this by? Good, 16. So that gives me 16 Rbs. 8 times 2, 16 Rbs. 8 sulfurs, 8 times 1, 8 sulfurs. It's balanced. So again, metals with sulfur. You just take the metal, but plus sulfur, S8, and whatever the name of the metal is, sulfide. So again, I'll go back to aluminum. Aluminum plus sulfur, aluminum sulfide. Calcium plus sulfur, calcium sulfide. The only difference is you just got to change the formula down here. Not hard. Almost done. 2 more. Okay, metals with halogens. This time it's different kinds of halogens. So M plus H2, notice I use a lowercase h. If I use a capital H, I didn't want to confuse you with hydrogens. So this lowercase h is for halogens. And notice there's a subscript 2 here because almost all the halogens, at least all, well, let me phrase this, all the halogens we'll use all are diatomic. So they have a subscript 2 there. And again, this makes a metal halide. Halide means halogen, but there's different halogens like fluorine, chlorine, bromine, iodine. Those are the 4 we'll use. Fluorine, chlorine, bromine, iodine. When there's a reaction between sodium and chlorine, write the word and chemical formulas. So again, just write out the metal, sodium, plus, I can make this a little bit better, plus my halogen. In this case, I say chlorine. So sodium plus chlorine makes a metal halide. Whatever the metal is sodium. And now that it's an ion, it's not chlorine anymore, it's chloride, sodium chloride. Next, write the formula. So that's Na plus Cl2, because chlorine's diatomic, makes Na, which is +1, and then chlorine, or chloride, which is -1. So that's done. Now balance it. 1 sodium, 1 sodium. Good. 2 chlorines, 1 chlorine. Not good. What can I multiply the smaller one by? Multiply by 2. Now that gives me 2 sodiums. So I got to put a 2 there. 2 sodium, 2 sodium. 2 chlorine, 2 chlorines. Done. And again, I'll pick pick aluminum again. Why not? Aluminum plus, well, this time we'll change it. Bromine, aluminum plus bromine, aluminum bromide. And then you just write the formula. Last one, and this is the hardest one. Reactions with oxides in water, specifically a metal oxide in water. So, metal oxides react with water to produce metal hydroxides. So, any metal oxide, MO, any metal oxide plus water, H2O, will give me a metal hydroxide. So, write the word formula when water is mixed with calcium oxide. So in this case, calcium oxide is my metal oxide. So I'm going to say, and again, it doesn't matter the order you write this technically. You could, well, on the reactant side is what I'm referring to. You could have said water plus metal oxide, just like I could have had the halogen plus the metal on the last one. That order, the reactant side order, does not matter. So I could put water first since that's the first thing they give me, but I'm not going to do that. Traditionally, I always just do it second. That's just the way I've always done it. It's just tradition for me. So I'll start with the calcium oxide. So I say calcium oxide plus water makes calcium hydroxide. And again, you just have to memorize these. That's it. You have to memorize them. There's no easy way of doing this. You have to memorize them. You have to accept that. You have to get over that fact. You just have to do it. You have to memorize these different kinds of synthesis reactions. You have to. There's no way around it. Sorry, but you have to. Now, for this one, again, it could be any metal oxide. I could, again, pick aluminum. Why not? Aluminum oxide plus water is aluminum hydroxide. Iron 2 oxide plus water is iron 2 hydroxide. That's all you do. So let's write the formula. Calcium oxide, Ca, plus 2. Oxides, O, -2. So plus 2, -2, they cancel. Water, H2O. And it makes calcium hydroxide. So calcium Ca plus 2. Hydroxides, OH, -1. So I need 2 hydroxides, so parentheses 2. And now I gotta balance it. 1 calcium, 1 calcium. Now watch this. 1 plus 1 more oxygen. There are 2 total oxygens on the reactant side. 2 oxygens. 2 times 1, 2 oxygens. So I got 1 and 1. There's those 2 oxygens. And here's 2 oxygens here. So 1 calcium, 1 calcium. 2 oxygens, 2 oxygens. Now 2 hydrogens. 2 times 1, 2 hydrogens. It's already balanced. Very simple, very easy one to do. And that's it for synthesis. That's it for synthesis. You just have to memorize these 5 kinds of synthesis reactions. But again, don't worry about the nonmetal plus oxygen one. That's not really important. So now you're really down to 4. And again, you have to know synthesis when you see it or when you read about it. How do you know when you just see it? Because again, it has 2 or more. All the ones we've had 2. It's 2 or more reactants and 1 product. That always makes one thing only. And that's it. All right. See you in the next one, which is over decomposition, which is perhaps the toughest, if not the second toughest kind of reaction. But they're fun to do in the lab.